The paper of the day is Massively Parallel Sort Merge Joins in Main Memory Multi-Core Database Systems. The two dominating hardware trends are increasing RAM sizes and ever more cores. Both facilitate the development of main memory databases that are essential to propel the operational and real-time business intelligence applications. To minimize query response time, that is, in their main memory database systems, Hyper, they devised a massively parallel algorithm for the most important query processing operator, the equijoin. MPSM merge joins in parallel sorted runs, which themselves were sorted by parallel threads. The performance analysis revealed that MPSM can effectively join very large main memory data of billions of tuples as it scales almost linearly with the number of cores. The scalable performance of MPSM is due to carefully exploiting the NUMA characteristics of the modern high-capacity servers. They avoided fine-grained synchronization and random access to remote NUMA memory partitions. The linear scalability in the number of cores promises MPSM to scale even beyond their tested 32-core 1 TB server, which is currently the top-of-the-line main memory server, but soon will be surpassed by the next generations of servers with several TB capacity and hundreds of cores. Looking at the experimental summary, paper showed that MPSM scales to very large data volumes and scales almost linearly to increasing number of cores. This indicates MPSM's future potential as the upcoming servers will have even more RAM and more cores, probably a few hundred soon to come. The superior performance characteristics of MPSM are corroborated by the observation that in their experiments they neither exploited any possibly existing sort order nor exploited the quasi-sortedness of the results. Let's look at the contributions of the paper. The paper showed that the carefully engineered NUMA-friendly MPSM exhibits an outstanding performance when compared to the Wisconsin hash join and vectorwise. The performance evaluation proves the scalability of MPSM for very large main memory databases with hundreds of GB data volume. For large number of cores, MPSM outperforms the recently proposed hash join Wisconsin join by up to an order of magnitude. MPSM scales almost linearly in the number of cores and compared to the TPCH endorsed world champion query processor vectorwise even achieves a factor of 4. Coming to PS score, overall this paper is a decent read, so it gets 7 out of 10 on readability. With 12 pages long, it scores 8 out of 10 on length. It's a measurement paper with decent description, so that makes it 8 out of 10. Its industry value and learning meter is good but not great, so it gets 7 out of 10 on each. Overall PS score is 7 out of 10.